Okay, this video will cover number 9 from the homework packet, where we will find the standard form equation of a line passing through a point once we have been given an equation of another line in slope-intercept form, or y equals mx plus b form. So let's take a look at the problem. Here is our problem number 9. It says passing through 4, 4 parallel to y equals negative 6x plus 5. So here's how we solve these types of problems. Don't worry about putting it in standard form for the time being. First, we actually have to find the equation of a line parallel to this line that passes through these 2 points. Okay, or this point represented by this x value and this y value. All right, so let me zoom in on my work here. Can everybody see that? Yeah? Okay. Alright, when I'm drawing a line that is parallel to another line, what aspect of the original equation remains the same? The slope. Very good. So if I have to, first I've got to identify the slope, and not this gentleman, somebody else tell me what the slope is. Negative 6. Very good. So m equals negative 6. Alright, now I've got to solve for this new line that I'm going to draw, which is going to be parallel to this line, but it's going to pass through these points right here. Now remember, I asked you to solve this using a graph and using algebra, right? Does anybody have a sheet of graph paper I can use? Thank you very much. Okay, so let's go to some graph paper here and get a straight edge. So let's graph the first line. This thing is all beat up. Okay, so here's my y and here's my x. We'll just increment these by box as 1. Hopefully I'll have drawn enough. 1, 2, 3, 4, 5, 6. This is 0. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to graph this first line. We have a y-intercept somewhere. What's the y-intercept? Can't hear you. What? 5. 5. All right, thank you. So first we put a little bubble there. And then I'm going to use my slope formula. I'm going to use the slope formula to do rise over run, which is negative 6 over 1. And I'm going to plot by going down 6 over 1. Down 6 over 1. So that would be starting from 5. Down 1, down 2, down 3, down 4, down 5, down 6 over 1. Y'all do another one. Plot another point, then use your straight edge to draw a straight line passing through those points that you plotted. it should look something like this. Alright, so now we've plotted this line. This line has a label on it. It is y equals negative 6x plus 5. Now I don't know where my other line will be, but I know that the slope of that line is going to be exactly the same. It's going to have this negative 6 slope going straight down. But let's find out what that is. So for now, you take your graph paper and put it aside, because we have to do some algebra. We will use the point-slope formula to solve for the new equation. Point slope, remember, is y minus y1 equals m, open parentheses, x minus x1, close parentheses. That's the point-slope formula. Now we actually have x1 and y1 right here, 4 comma 4. So when I substitute in my values, we're going to substitute in y1 right here, x1 right there, and then for slope m we'll use negative 6, which we found already. We don't need this y-intercept anymore. So I'll substitute in y minus 4 equals negative 6, open paren, x minus 4, close paren. Well, now my goal is to distribute the negative 6 inside the parentheses. So just y minus 4 equals negative 6x. Somebody tell me, what is negative 6 times negative 4? Positive 24, plus 24. Okay, so I'm almost done. I just have to plus out the 4 on the left and add it to the right. So I have y equals negative 6x plus 28. Well, unfortunately, if I go back to my graph paper here, there is no way I'm going to be able to plot 28 lines up. You see the thing that's wrong there? I can't do that. So I wonder, is there any way I could find out where this thing crosses the x-axis? Since I'm not going to be able to plot it on the y-axis, I would love to find out where it crosses on the x-axis. So this is a little bit of a departure from the problem, but let me show you the equation of the line we just found. It's y equals negative 6x plus 28. So we can't plot 28 as the y-intercept. So maybe we can plot the x-intercept. Remember, the y-intercept of any line is where x equals 0. See, here's x. Where x is 0, the y-intercept is 5 for this line. Where x is 0, the y-intercept is 28 for this line. What about the x-intercept? That is, where does this thing cross the x-axis? Because I might be able to plot that. Well, here's how I would find that. We assume where the x-intercept is, look where y is. Y is 0. So the way I can actually find out where this thing crosses the x-axis is by substituting in a 0 for y. So now 0 equals negative 6x plus 28. Let's now solve for x. Solve for x. This is how you find the x-intercept. So what you do is set y equal to 0. So there, I did that. Now solve for x. What I'm going to do is subtract out 28 on both sides. Now I have negative 28 equals negative 6x. And I will divide out negative 6 on both sides. So I'll divide out negative 6 on both sides. Now I have x by itself. That's the intercept. I just need to find out what negative 28 divided by negative 6 is. What did you get? It's the same thing as 28 divided by 6. 4 point what? 4.7. Okay, so close to 4.7. Is that what everyone else is getting? Somebody confirm that. Okay, so really it's 4 2/3. But yeah, 4.7 works fine. So what we're going to do is plot this point as close as we can on our graph. See, we got that point right there, 4.7. It's a little bit past the halfway point on the way to 5. See that? So now I've got the same slope. So starting now at my x-intercept, I'm going to go down 6 over 1. So down 1, down 2, down 3, down 4, down 5, down 6, over 1. So it's kind of a advanced thing to do there, but we couldn't, since we couldn't plot the y-intercept, we can plot the x-intercept. It works exactly the same way. Because look, if I did this correctly, I should have a line that is essentially parallel to the one I just drew. And I did. It is. So this one is y equals, because if this line were to keep going up and I had graph paper, eventually it would hit that y-axis at 28. This is y equals negative 6x plus 28. All right, let's go back to our paper. Write the standard form of the equation of the line described. This is really easy. So all that work was to get to where we're going to do this super easy thing. So let's take our equation, y equals negative 6x plus 28, and now we're going to find the standard form. Well, what does the standard form look like? Well, here's what it looks like. ax plus by equals c. What you say are a, b, c? Well, it's pretty simple. Here's your y factor. Here's your x factor with the a in front of it. Okay, what's the b factor? It's hiding invisibly here. What's the b factor? 1, right? And here's the c factor, 28. So what I'm going to do is plus out the 6x on both sides of my equation, plus 6x. Now I have 6x plus y equals 28. See that? That is the standard form of the equation of the line. So once we got the equation of the line in slope-intercept form, right here, to turn it into standard form was really, really simple, wasn't it? We literally just did plus 6x. You see that? Now, why is standard form useful? That's something we'll get to later. But right now, it's good to know how to write it. So when you see a line in standard form, you can always get this line into slope-intercept form real easily. When we put it back in slope-intercept form, we would just subtract out 6x on both sides, and we would have y equals negative 6x plus 28. So we're really just switching between notation styles, one form to another, slope-intercept to standard, standard to slope-intercept. And that's how you do number 9, number 10, and then down here on number 13 and 14, you have an even easier task. So you have y equals 3x plus 1. Well, if I want the standard form, what am I going to do? subtract 3x from both sides. So I have negative 3x plus y equals 1. Okay? Sometimes they want the standard form to only have positive coefficients, but just leave it like that for now. That's what I'll accept. There's your standard form equation of the line. Okay, so that was, I guess, 9 and 13. So just to show that again, for number 9, I need to see all of this work, so freeze frame there and copy that down, and then I need to see all of this work. And I'll zoom out real quick to show the whole thing and then kill the video. Let me zoom out. So for number 9, I need to see basically all of that. That's number 9. This work down here that we did, you didn't have to do that if you had drawn a huge graph. But since we didn't draw a huge graph, this is a little trick to use when you don't have the ability to plot the y-intercept. It's a workaround. Ideally, you could plot the y-intercept. So we could have saved ourselves a lot of grief by just drawing a huge graph. So don't worry about using too much graph paper. So I'll leave it there. That is how you do number 9. And then number 13 was just already, it was much easier than number 9. In a way, we were just moving values around. Number 13. Okay, so we'll end the video there. Thank you very much for watching. Please make sure to like and subscribe.